Welcome to the course on Introduction to the Natural Language Processing. My name is Amrish Patil and today we are going to discuss about encoding methods used in natural language processing. Before going into deep, we must understand how machine understand your words or your sentences. In a world dominated by words, NLP stands as an unsung hero. It's not just about recognizing the language, it's about understanding the subtleties, the context, and the emotions behind the every words. Imagine a word where your device don't just process the commands but understand your intent. And this is the most important thing in NLP. Because whatever sentence you use, every sentence have different context. They have different semantic, they have different syntaxes, they have different intent and emotions behind this. So our major objective to make sure that our machine will not only understand the words but understand your intent. So such kind of applications will help us find data patterns, linguistic models that make our human machine interaction more efficient. So what is encoding? To put it simply, encoding is like a translating human language into a form that computer can understand. It's the bridge that allows machine to grasp the nouns and meaning embedded in our words. In NLP, encoding is the key to unlock the treasure trove of information within the text. Now, let's take one example. Let's consider the sentence, I love natural language processing. If we apply a sample encoding, we represent this sentence in a numerical format. For simplicity, let's assign each word a unique number. For example, I is equal to 1, love is equal to 2, natural is equal to 3, language is equal to 4 and processing is equal to 5. Now, if you converted or if you see the encoded versions of a sentence, so that would be 1, 2, 3, 4 and 5. So why does this encoding matters? Think of it as a preparing a dish. You need the right ingredients in the right form. Similarly, for NLP tasks like sentiment analysis, machine translation or chatbot, the computer needs the right ingredients, that is, the rightly coded information to work its magic. Now, what are the types of encoding? There are different types of encoding methods available, like one-hot encoding, n-gram language model, bag of word language model, word to vec, TF-IDF model, and many more. In today's session, we will focus on one-hot encoding method, since it is one of the oldest method which is used for encoding. So what is one-hot encoding method? One-hot encoding is a technique in the natural language processing that converts a word into binary format, allowing computers to comprehend and analyze the textual data efficiently. Let's break down how it works. Now, the process starts with the tokenizer, where each word in a sentence is identified and isolated. For instance, consider the sentence, machine learning is fascinating. So, the tokens are machine, learning, is, and last one is fascinating. Second step is building the vocabulary. In this step, the vocabulary is constructed. So it basically comprises all unique words present in a dataset. For example, in our dataset or in our sentence, the vocabulary will be machine, learning, is, fascinating. So always remember, vocabulary always consists of unique words which are present in your sentence. So the length of a unique word makes the size of our vector. Now, the last step is representation. So what we have to do, we have to represent our uh, sentences in a form of a binary vector. The length of a vector equals the size of a vocabulary. For word is present, its corresponding position in a vector is marked as a 1 and 0 if not present. For example, machine is represented by 1, 0, 0, 0. Learning is represented as 0, 1, 0, 0. Is represented as 0, 0, 1, 0. Fascinating is represented as 0, 0, 0, 1. So it is the most common method, or we can say it is the most simplest method to convert your words into numerical form. But it have some kind of problems. What are they? So first problem is high dimensionality. So as you can see, one-hot encoding results in high dimensional vectors. For example, if we're dealing with the sentence which consists a large number of unique words, that means the vocabulary size is very large. So in such kind of scenario, it will create a very high dimensional vectors that are complex to understand and complex to process. Second most important problem is lack of semantic information. So the binary nature of one-hot encoding doesn't capture the semantic relationship between the words. That means we or machine will never understand the meaning behind the word because each word is considered as a separate entity. Next problem is a sparse representation. What is mean by that? Most words in a sentence are irrelevant to the current context. As a consequence, one-hot encoding creates the sparse vector mostly with zero value and making it inefficient for storage and computation. And last one is not suitable for continuous data. So one-hot encoding is basically primarily designed for categorical data only. So that makes it less suitable for representing the continuous variable. So these are some problems of one-hot encoding. That's why the one-hot encode is not really used whenever you deals with the practical or whenever you deals with the large sentences. At the conclusion, ambiguities, slang, and context nouns can make encoding a tricky task. But we don't have to fear because the algorithms are continuously evolving to tackle this hurdle. And we will uncover some of this in our next video. Till then, goodbye and we'll see in the next video.